Welcome. Quantum AI ML Science Fair 2025. F0Z Agent Simulation Explorer Module. Circularity Explorer Lab. This lab is dedicated to the exploratory process of identifying and understanding circularity in complex systems. Use the LLM-powered analysis engine to examine system descriptions for feedback loops, recursive patterns, and self-referential dynamics. Explore F0Z concepts that inherently involve or manage circular processes. Circularity Analysis Engine, LLM-powered. Describe a system, scenario, or a set of interacting components. The LLM will attempt to identify and explain potential circularities. System description/scenario. The highest priced skill a human can have is detecting circularity. My impression is that AI is structurally incapable of it. Analyze for circularity. LLM analysis results. Here is an analysis of the provided system description focusing on potential circularities, feedback loops, and self-referential aspects, interpreted through the F0Z framework. The statement, the highest priced skill a human can have is detecting circularity. My impression is that AI is structurally incapable of it, presents a perspective on cognitive capabilities and limitations. While brief, it touches upon complex concepts involving human cognition, artificial intelligence, value assignment, and the nature of circularity itself. Analyzing this description reveals several potential areas where circularity, in various forms, might be relevant. 1. Circularity in the definition and valuation of the skill *** circular pattern ***. The statement posits that detecting circularity is the highest priced skill. This assigns value based on a perceived difficulty or uniqueness, implicitly, something AI cannot do. How is this price or value determined? It likely arises from contexts where detecting circularity is crucial for avoiding errors, paradoxes, or systemic failures, e.g., in logic, system design, economics, debugging. But the recognition of its value might itself require the ability to detect the negative consequences of failing to detect circularity, consequences that might arise from unchecked feedback loops or self-referential errors. Thus, the value of the skill is determined by the problems caused by its absence, problems that are fundamentally circular in nature. This creates a valuation feedback loop. Circularity detection is valuable because unchecked circularity is harmful. Recognizing the harm of unchecked circularity requires circularity detection. Implications. This circularity doesn't necessarily imply a logical flaw but highlights a self-reinforcing aspect of assigning value to this skill. It underscores that the problem that the skill solves, dealing with circularity, is intrinsically linked to the skill itself. This can lead to a high, potentially ever-increasing, perceived value as systems become more complex and prone to subtle circularities. It could also lead to a confirmation bias where evidence of circularity detection's utility is readily accepted, reinforcing its value. F0Z modeling this can be modeled as a positive feedback loop within the value system, a subsystem. The detection of harmful circular effects, feedback, reinforces the perceived value of the skill, gain, leading to increased focus on detecting those effects, further increasing perceived value. The price or value acts as an amplification factor. The zero-state/origin could relate to the initial conditions of a system or domain where circularity first becomes a significant problem, establishing the context for the skill's emergence and valuation. 2. Circularity improving AI's incapability circular pattern the assertion is that AI is structurally incapable of detecting circularity. Proving a universal negative, structurally incapable, is inherently difficult, especially for abstract concepts like detecting circularity in a general sense across all possible AI architectures. Any attempt to formally prove this might itself risk circularity or infinite regress. For example, defining the scope of circularity that AI must fail to detect might require a metalanguage or framework, the consistency of which might rely on circularity detection principles. Furthermore, any AI system designed to test another AI for this capability might implicitly embody or avoid the very circularity it's trying to detect. The observer's judgment of incapable might also be circular, based on criteria derived from human cognition, which may involve circular or self-referential processes. Implications. This circularity highlights the philosophical and practical challenges in defining and proving the limits of AI capabilities, particularly for higher-order cognitive functions or abstract reasoning. It suggests that the assessment itself might be constrained by the nature of the skill being assessed. It can lead to an impasse in research or a focus on empirical demonstration. AI fails on task X, rather than theoretical proof. AI cannot do task X structurally. F0Z modeling proving universal incapability can be seen as an attempt to reach a stable zero-state/origin, a state of definitive proof or boundary, in the space of AI capabilities. The difficulty lies in the potential for an infinite feedback loop in the proof process itself, the requirements for the proof recursively depending on the concept being proven or the system's boundaries being ill-defined. It touches on the limits of formal systems, potentially related to Gödel's incompleteness theorems, which deal with self-reference and unprovability within systems, a form of inherent circularity. 3. The observer's self-referential loop circular pattern the statement is, my impression is that AI is structurally incapable. This is an observation made by a human, This human observer, who values circularity detection highly, highest priced skill, observes its apparent absence in AI. This observation reinforces the human's belief in their own possession of this valuable skill and the validity of their valuation. The human's framework for identifying circularity, used to assess AI, is also the source of the skill they value in themselves. This creates a self-referential loop where the observer's assessment criteria and perceived capabilities reinforce each other. Implications. This introduces observer bias. The very criteria used to judge AI's lack of capability are derived from the human's own cognitive framework, which they value. This can lead to a lack of imagination regarding how an AI might detect circularity using fundamentally different mechanisms, or a dismissal of AI behaviors that could be interpreted as circularity detection but don't match the human model. It's a form of anthropocentric circularity in evaluation. F0Z modeling this is a straightforward positive feedback loop centered on the observer, zero-state/origin as the observer's perspective/internal state. The observation of AI incapability, input, reinforces the belief in human capability and its value, internal state/gain, which in turn shapes subsequent observations and interpretations, amplifying the initial impression. This loop primarily affects the perception and valuation subsystem rather than the inherent capabilities of AI. 4. Potential circularity in AI learning or emergence of capability circular pattern if AI were to learn or somehow develop the capacity for detecting circularity, the process itself might involve circular dynamics. Machine learning often relies on feedback loops, e.g., error correction, gradient descent. Teaching circularity detection might require providing examples and non-examples of circularity. Generating or labeling these examples reliably often presupposes an understanding of circularity. This could lead to a bootstrapping problem. How can you learn to detect circularity if the process requires you to already have some grasp of the concept to structure the learning data or evaluate performance? This is a form of chicken and egg circularity in the learning process. Implications. This highlights a fundamental challenge for AI in acquiring truly abstract, structural understanding versus merely learning to recognize patterns correlated with instances of circularity in the training data. It raises questions about whether such a capability can be learned through standard methods or if it requires a fundamentally different, potentially emergent, architectural property. F0Z modeling the learning process is a feedback loop. The challenge in learning circularity detection could manifest as oscillation if the AI struggles to converge on a stable model, perhaps oscillating between over-identifying and under-identifying instances. The bootstrapping problem relates to the zero-state/origin. How does the learning process initiate or ground itself without a pre-existing external source of truth about circularity that doesn't itself rely on the concept? It could be modeled as a system where the required initial state, labeled data, guiding principle, is dependent on the system's desired final state, the ability to detect circularity. In conclusion, the statement, while simple, prompts consideration of several forms of circularity related to definition, proof, observation, and learning, all of which are critical aspects when analyzing complex systems like human cognition and artificial intelligence. The F0Z framework provides a lens to model these as feedback loops influencing dynamics, value, belief, learning convergence, and challenges related to system boundaries and foundational states, definition, proof, learning origin. Relevant F0Z concepts for circularity. Certain F0Z formulas and concepts inherently describe or manage iterative feedback, recursive operations, or adaptive loops. Explore these foundational ideas that contribute to understanding circular dynamics.